In this lecture, we will be looking at non-right triangles, solving non-right triangles using the law of cosines. So we've looked at law of sines, so now we're going to look at law of cosines. So in a similar way to how we derive the law of sines, we can derive the law of cosines, but we don't have to do that today because you do not have to regurgitate it, especially since we're strictly online right now. But the law of cosine states that the square of any two sides of a triangle is equal to the sum of the squares of the other two sides, okay, minus 2 times the product of the other two sides. So for instance, if we look here, we see that a squared is equal to b squared plus c squared minus 2 times bc times cosine of the angle in question, which is alpha. And this relates to all the sides of the triangle. So we can have b squared in terms of the other sides. We can have c squared in terms of the other sides. Now, if you want to find the angle in your triangle, in your right, well, it's not right, but in your triangle, your oblique triangle, this is the equations that we can use for alpha, beta, and gamma, respectively. Really, all we did was solve the equations before for cosine alpha, cosine beta, and cosine gamma. So let's look at some examples in which we would have to, or we can use the law of cosines to solve our oblique triangles. Here we're asked to find the unknown side and angle of the triangle given. So in this instance, our unknown side is B, and our unknown angles are alpha and gamma. So if we're looking for b, we know that we can use the formula where b squared is what? A squared plus c squared, so the sums of the squares of the other two sides minus 2 times the other two sides, right, times cosine of the angle in question, in this case, beta. So all we're going to do is plug in. So that means b squared equals a squared, which is 10, plus c squared, c is 12, minus 2 times a, which is 10 times c, and cosine of 30 degrees. So if we plug all of this in, well, this will become 100 plus 144 minus 240. And we should know that cosine of 30 degrees is going to be root 3 divided by 2. So I'm just simplifying at this point. Okay, so what we really have here is 244 minus 240 times root 3 over 2. Okay. If we want to get b, so this is b squared. Of course, we take the square root of both sides. And so b equals the square root of 244 minus 240 times root 3 over 2. Okay. And if you plug this in your calculator, you'll get that b is roughly 6.013. Okay. So that's b, but we also need to figure out what is alpha and gamma. So we know that, okay, we can use sine, the law of cosine, to find the actual side, b. And actually, you could use the law of sine as well, but we wanted to practice this. So now that we want to find the missing angles, we can also use the law of sines. Okay, so because we have b, we can use the relationship, because previously we didn't have b, and we didn't have alpha or gamma, so we really couldn't use the law of sines. But now that we have b, we can use that relationship, that sine of that ratio over b, and we can use that now to find alpha or gamma, whichever one we choose. So B is 30. And we recall that when we do the square root of a number, we take the plus or minus, but because we're talking about distance, we took the positive value here, okay? All right, so now B for us is going to be 6.013, and that's going to be equal to sine of alpha, we don't know what alpha is, divided by A, which is 10. We can cross multiply. We know that 10 times sine of 30, but we know sine of 30, right? That's going to be, well, we don't even have to, we can just put it in the calculator as is. We don't have to, yeah, equals 6.013 times sine of alpha, right? And so make some space here. And so since we want sorry dear, oh there we go. Since we want alpha, we can divide both sides by 6.013, so we'll have 10 sine of 30 divided by 6.013, and that will give us sine of alpha, and we know to get alpha, we take the inverse of this thing. So we do sine inverse, 10 sine 30, 6.1013, okay? And then once you plug this in the calculator, well, we should get alpha in degrees should be 56.3, okay? All right, and then in a similar way, we can also find gamma. So since we know what alpha is, you can really use any angle relationship here where we have the angle in the corresponding side. Or we can even just we know that all the sides of a triangle should be 180. So if we so gamma is 180 minus 30 plus 56.3. That will give us gamma. So with this, gamma is going to be 93.7 degrees. Okay. So in an instance where we are missing a corresponding side or angle relationship where we can utilize our sine, our law of sines, then we can always use the law of cosines. Okay, let's try another example. So here we're asked to find angle alpha for the given triangle. If side A is 20, side B is 25, and side C is 18. So usually with this, you can draw a sketch here, right? So it doesn't matter how you draw your triangle, you just have to make sure your sides are accurate. Let's say we do alpha, beta, and gamma here. So then A is opposite of alpha, B is opposite of beta. This is always how you will label your triangles. C is opposite of gamma. So they're saying that this is 20, B is 25, and C is 18. Okay. Before it dies on me. Okay. All right, so now with that being said, if we want to solve for alpha, right? If we want to solve for alpha, so the first thing we can do is, since again we do not have a relationship with any angle here because we don't have any angle, so we can't utilize law of sines. So what that means is we're going to have to utilize our law of cosines. So that means since we're looking for alpha, I'm going to use the relationship that has alpha in it. So a squared equals the square of the other two sides minus 2 times cosine, well, the product again of the other two sides, so b times c, and then cosine of alpha. So we can plug in. We know a is 20. B is given as 25. C is given as 18. Okay, so this would be 25, 18. And then we don't know what alpha is, so we're going to leave that. And so 20 squared is 400. 25 squared is 625. 18 squared is 324. And that will be minus, if we do the product of all of these, it would be 900. And then cosine alpha. If we do the sum of these, that will give us 944 minus 949 minus 900 cosine alpha. Of course, we subtract 949 from both sides. And so we get negative 549 equals negative 900 cosine alpha. Divide both sides by negative 900. So now we're just doing algebra. Okay, this would be 0.61 is going to be cosine alpha. Of course, we know to find alpha, we do the inverse. And so alpha is going to be 52.4 degrees. Okay, and if you wanted to find the other sides, of course you could. Now you could utilize your sine, your laws of sines, if you wanted to find the other missing angles. Okay, let's do a application problem. So on many cell phones with GPS, an approximate location can be given by the GPS signal before the GPS signal is received. This is accomplished through a process called triangulation, which works by using the distance from two known points. Suppose that there are two cell phone towers within range of a cell phone. The two towers are located 6,000 feet apart along a straight highway running east to west, and the cell phone is north of the highway. Based on this signal delay, it can be determined that the signal is 5,050 feet from the first tower and 2,420 feet from the second tower. So we want to determine the position of the cell phone north and east of the first tower and determine how far it is from the highway. So quite a bit of information in here. But if we were to do a nice little diagram. All right, so we have two towers. Okay, so they have two towers that are 6,000 feet apart. So let's say we have two towers. I'm not an artist here. We're going to say that's a tower. So these are my two towers, 6,000 feet apart. Okay, on a straight line. So this is my highway. Based on the signal delay, it can be determined that the signal is 5,050 feet from the first tower. So let this be my first tower. So that means this is 5,050 feet away. So this is my cell phone. Now, something like so. That's my cell phone. Okay, so my cell phone, it's from 5,050 feet from the first tower, and then it's 2,000. See, there we go. It's 2,420 feet from the second tower. Very good. Now we don't have any angles, if you notice, right? We only have sides. So here we're told to determine the position of the cell phone north and east of the first tower. So north and east would be this location, and we're trying to determine the position of the cell phone. Okay, so we need to be looking at then this degree here. This is going to be our theta. Okay, so because we're looking at the position north and east, so that is going to be where the cell phone is. So determine the position of the cell phone north and east of the first tower. So that's going to be where theta is, and determine how far it is from the highway. Okay, so where it is from the highway, we'll deal with that later. That's going to bring in another piece. But we can use the law of cosine to figure out what theta is, right? By using A, B, and C, and so forth. So in this instance, they didn't tell us what theta is, if it's alpha, beta, gamma. So we can just label it however we want. So let's say this is alpha, then this means this is A. Really doesn't matter how else we label things. Okay, we just need to make sure, we're labeling them correctly. So I'm going to let this second tower be beta, and then the cell phone is going to be at gamma. So with that being said, always make sure B is opposite of beta, C is opposite of gamma, A is opposite of alpha. So I'm using my relationship. A squared equals B squared plus C squared minus 2BC, right? Cosine alpha. And alpha is the angle we're looking for. So in this instance, A is 2420. B, based on my label, is 5050. C is 6,000. Two times B. C. Cosine alpha, we don't know. Alrighty, so I'll just bring these over, and really you can just put this in your calculator. These are going to be some huge numbers, so I'm just going to keep them as is, and then you can put them in your calculator when you're doing the calculation as such. And so be equal to -2 times 5050, 6,000 cosine alpha. Then we're going to divide by this thing here. Okay. So this means that if you plug this in your calculator, you should get, so plug in all of this on the left-hand side in the calculator, you should get 0.9183 is equal to cosine alpha. And then recall that alpha is my theta in this case. Now, if I take cosine inverse, right? Cosine inverse, I should get what alpha is. And so that means, plug in again in the calculator, alpha is going to be 23.3 degrees. Okay, so that's how we would do a application problem. Okay, so now as it relates to the second part, we're asked to find now how far is it from the highway. So this is another piece of the puzzle. The distance from the highway is actually a straight line, which is the height of the triangle. And so in this instance, we're trying to find the height of the triangle. So if we were to label this, let's say y or something. So this is going to be now my triangle here. We just found theta is 23.3, so I'm going to write that in. Okay, so theta is 23.3. Now this becomes just a regular right triangle, right? So something like so. Okay, this is y, and this is 50-50. But notice here, the whole thing here from the poles is 6,000 feet. But we don't know what this piece is, right? Because this whole thing is 6,000. So we don't know what this, because we don't know what these two sides split are. Okay, but what can we use? We can use our regular functions that we've done before to find, x and y. Okay, so for instance, if we think about cosine of this angle, cosine of theta, which is 23.3. We know that cosine is going to be what? Based on SOHCAHTOA, it's going to be adjacent, whatever adjacent is. In this case, adjacent is x over my hypotenuse, which is 50-50. So if I do cross multiplication, that means 50-50 times cosine of 23.3 will give me x. Now plugging this in my calculator, we'll get that 4,638.15 feet is x. 4,638. So that's going to be my x. Now I need to figure out what y is, but if I do sine, I can figure out what y is. So sine of 23.3 will be what? Opposite, which is y over hypotenuse. Okay, we can also plug this in our calculator. If we multiply, cross multiply. So this means that y is going to be 1997.5 feet. Okay, so that means that the cell phone is 997.5. We could say 199.8 feet from the highway. Okay. All right, so now we're going to talk about Heron's formula. Now, basically, Heron's formula comes into play when we are looking at the area of a triangle, okay? Okay, and so basically what Heron's formula tells us is that to find the area of an oblique triangle, it will be area equals the square root of S. Now in this case, S is just the average, well, not really the average. S is going to be the sum of your sides divided by 2, which is half of your perimeter, or sometimes called your semi-perimeter. So S times S minus A, S minus B times S minus C. And so if we're finding the area of an oblique triangle, we can use Heron's formula. Of course, we know a regular right triangle is half base times height. So for instance, let's say we have this and we want to find the area. All right, so of course, first we'll need to figure out, well, what is this S that we speak of, right? The semi-perimeter. Well, we're adding all the sides, dividing it by 2. So this becomes 7 plus 10 plus 15 divided by 2. And so we'll get, this is going to be 16. Okay, so that's going to be 16. All right, and so now what we're going to do is plug this into the Heron's formula. So A, we know that the area equals the square root of S. I'm just going to rewrite it. So this is going to be the square root of 16 times 16 minus A, which is 10. 16 minus 15. And 16 minus 7. Simplified, just plugging it in your calculator, you should get 29.4 roughly. And that's how you find the area. All right, so we'll stop here for today. Be sure to look out for your homework that will be released right after class or with this lecture. All right, have a great day, guys.